Hey everybody, this is James Tierney from Tierney Education. I'm going to answer this question that was submitted from a current student where we're trying to find a firm's marginal cost of production when we're given a few things. So remember, the marginal cost is always my change in total cost divided by my change in quantity, which really this is going to be the first derivative of total cost. So if I want to answer marginal cost, I need total cost. That's going to be where we need to start. Total cost in this type of question where we have two inputs, capital and labor, your total cost is going to equal your wage times your number of workers. So that makes sense. If I have 10 workers, they're each making $5, it'd be $50, plus the rental rate of capital times your number of capital. So we're going to need this. So how do we get that? Well, first let's plug in what we know. And total cost equals, let's go back to our question. We know that K is 9, we know that W is 6. It's everything we kind of know for now. So wage is 6 times L. We don't know R, K is 9. So we have my total cost is equal to 6 times L plus R times 9. The next thing we notice here is it wants us to know what the marginal cost is when the firm is producing 6 units of output. So this 6 units of output means that when quantity is equal to 6. So that means I need total cost as a function of quantity so I can plug in, I can find the marginal cost, right, as quantity, and then I can plug in 6. That's what I need to do. So how, again, am I going to do this? What we're going to do is we're going to get L in terms of Q. Basically, that means L as a function of Q, meaning what would be the labor needed to do this quantity. So let's go with what we're given, right? We have up here my production function. Q is equal to L to the 1/2, K to the 1/2. I'm going to write this a little differently to make it easier to look. This is going to be Q square root of L times K, right? Because I can combine these two. It's the same exponent, so I can just end up combining them as one term, L times K. And then 1/2 is a square root because most students see square root and then they say, okay, I can solve this. Because what I'm going to do is I'm going to square both sides. So that's going to tell me that Q squared equals L times K. And if I divide both sides by K, then what I know is I know L as a function of Q is equal to Q squared divided by K. This is really important. And as we continue in this class, so this class is Econ 302 at Penn State University, we're going to need this a lot. So it's good to know that. I'm going to scroll down a little bit, so if you need to pause and write some stuff down, that's perfectly fine, but let's scroll down this a little bit. I'm also going to change colors to show that we're kind of doing something, the next step, let's say. So now total cost, but instead of L, we are plugging in Q squared over K, right? That's over here, we're just plugging that in over there. And then plus R times K. Now we do know what K is. We can scroll up and you can see that K is fixed at 9, which is also where we get the short run because one of our inputs is fixed. So let's scroll back down and let's plug in 9 for K. So we know my total cost is equal to 6Q squared over 9 plus 9 times R. Now we can also simplify this, right? Those are both going to be divisible by 3, so it's going to be 2/3. So we know total cost as a function of quantity is equal to 2/3 Q squared plus 9R. And at this point, you might be saying, man, we don't know what R is. And that is true, we don't. Meaning we don't know what total cost is. But the question is not asking for total cost. The question is asking us to solve for marginal cost. So let's do marginal cost. Remember, marginal cost is going to be the change in the total cost. So that's our first derivative. So we're taking the first derivative of this. And notice, right, R, that's just a number. So that's not going to change. How is total cost going to change when we see our quantity changing? And so our first derivative of this function, my marginal cost as a function of quantity, I'm going to bring that 2 down from the exponent. So it's going to be 2 times 2 over 3 q plus 0 if you really want, right? Because how is total cost changing when 9r change? Well, 9r does not, like, that's not changing, right? So like how's it gonna change with respect to q? This does not change when q changes. So we've now found our function for marginal cost. Marginal cost as a function of quantity is going to be equal to 4 over 3q. And so as quantity changes, this is how my marginal cost is going to change. And if I scroll up to see exactly what this was asking, remember, this was asking us marginal cost of production when the firm is producing 6 units of output. So Q equals to 6. I go back down here. I already have this. I want to now find my marginal cost when Q is equal to 6, which means it's going to be 4 over 3 times 6. The 3 and the 6 will cancel to become 1 and a 2. So my marginal cost when Q is equal to 6 is going to equal 8. That's how you would solve this type of question. Now, as a quick recap, the steps we care about, right? The steps we care about, I'm actually going to make this kind of smaller so you can kind of see everything at once. If it's too small, I'm sorry, you can always go back. We know what marginal cost is, which is going to be my first derivative of total cost. So I need the total cost. That's our first step. You got to know this equation, wage times L, R times K. But we know a lot of the stuff. We know that wage is 6. We know that K is 9. So I need to get this in terms of Q. I need my total cost in terms of Q. Well, here I have an L. I just need to rearrange my production function to get L in terms of Q as a function of Q. And then take this and plug it in, right? 6 times L is just 6 times Q squared over K. Plug in my K's, get it down to a functional form that I can easily take a first derivative of. And remember the first derivative, we pull our exponent down in front. We subtract 1 from the exponent. That's why we're pulling the 2 down in front. And now our exponent is 1, right? Quantity, changing quantity has nothing to do with this. That's going to be a 0. So I'm left with 4/3 Q. That's my marginal cost function. I'm just now going to plug in the 6 that I need to solve out for 8. I hope this was helpful, both to the student who asked about it, but also anyone else who comes across this. Again, hopefully we'll see you soon.